All right, welcome back. So now we're going to look at Newton's use of calculus in physics using derivative, really, and this is a perfect example of it. So an object thrown upward at time t0 with an initial velocity of 49 meters per second. It has a height y meters and given by this function y equal to negative 4.9 t squared plus 49 t seconds later until it falls back to the ground again. And there are three questions that we'd like to answer. One is, what is the acceleration at any time? And B, how high does the object get? And C, how long does it remain in the air? Now, those of you who are taking Physics 11 or Physics 12, part of a kinematics chapter, you actually can solve this differently, but we're going to use calculus for this for the purpose of this question, because this is a calculus question and calculus in a calculus course. So let's use this because actually, in all fairness, Newton used calculus first. He did the derivative of the actual formula that you are used to. All right, first, we know that Vt, which is the velocity, is the change in distance over change in time. Okay, so dy dt, that's Vt. So in this case, we want to take the derivative of y and this function y, let's call it y prime. So in this case, at, let me write it down as at, which is acceleration function, is actually the change in velocity dv over dt. Okay, so, and now that we have this, let's go and find out what these are. First of all, this, the Vt is the derivative of what this is. So that would be negative 9.8 t plus 49. So I want to make sure that you understood this part, okay? So the first thing that we did, to get the velocity function, we need to take the derivative of the distance function is given to us right here. And that's what we did. Change in distance over change in time. So basically what we've done, we took the derivative of y. Let's call this y prime, and that's what that is. So whatever you get, the y prime, that is your velocity function. Now, to get the acceleration, you have to take the derivative of the velocity function. And the velocity function, which is right here, y prime, that is negative 9.8 meters per second squared based on the rules of derivative. All right, now that we have this, let's get into how high does the object get. Well, that's very easy, because at this part, we know that Vt at the end, we know that the velocity itself, when it gets to the top, it stops. It doesn't move anymore. So that's 0. So that means we can just go ahead and just say, well, this is negative 9.8 t plus 49, set that equal to 0, and then find what t is. And do a quick calculation. You'll get in, okay, 4.9 divided by 9.5. Actually, it is 5. That's about 5 seconds. All right. So that's what you will get. Very good. So now that we have this, we want to know the time is 5 seconds that it's been basically moving upward, and we want to know how high. That means now we got to go back and plug the value of t into the original y function, the distance function, which is up here. So we're going to plug it in here for t and then rewrite. All right, let's do that. So I plugged in the 5 seconds value into the y function, the distance function, and when you do the math, you end up getting 122.5 meters. This is the highest distance or altitude that the object will get, sending an object up at 49 meters per second squared at initial velocity. All right, and the last step or last question is, how long does it remain in the air? Now remember, when you start throwing the ball up, the ball goes up, sorry, the object, that's still the object, goes up and goes to the top and then comes down. We want to know the entire, so we know the height here, but we don't know how long does it take going from the entire path. This projectile path takes t time, so we want to know. Now, given the fact that it took from here to the top, this value or this time value was 5 seconds, well, it stands to reason that it's coming down the same rate in terms of time, and that is true because its parabolic is symmetric. So that means it will take 5 seconds to come down. So that means the total time of the flight is 10 seconds, okay? From the initial launch to the time that it falls back to the same level. All right, so that would be 10 seconds that the object is in air. Now, I used this common sense kind of analysis or deductive reasoning to come up with 10 seconds, but we can actually use the equation. Okay, so we can go back up there, but we do know why, because the entire path, when it goes up, from the moment it leaves the ground and then comes down to the ground, the total vertical distance will be 0. So if that's the case, what we can really do is set up the equation like this: 4.9 t squared plus 49t, and you set that equal to 0 because y value is 0. All right, and then in this case you can use factoring, and that becomes negative 4.9 t plus 49. Set that equal to 0. So you got two options. You can solve this quadratic basically. T is 0 seconds, which makes sense. At 0 seconds the height is 0, or you get minus 4.9 t plus 49, set that equal to 0, and then t will end up being 10 seconds. So this is the algebraic way of doing it, and which matches what we talked about. So it's either 0 in the air or 10 seconds. So in this case, we have to take the 10 seconds because that is the total path that is traveled, and therefore it took 10 seconds to completely cover that path. All right, so here is the final answer to this question. All right, so here is a great example how Newton used calculus and derivative to explain motion, because that was the original purpose of calculus. Newton created that because he couldn't use the typical mathematics in terms of algebra and operational algebraic operations to deal with the change in the problem. So change in velocity, change in distance, change in time, change in acceleration, any of those things, he couldn't. And of course, the whole classical physics is based on that. All right. Well, thank you so much. Well, I hope this was useful. Come back again. Until next time, keep well.